Every single living thing on Earth is currently being touched by one singular invisible force. Welcome to this explainer. Today, we're breaking down the mechanics, the global impacts, and the concrete solutions surrounding the rapid global warming of our planet. We're going to unpack exactly how this fundamental shift works and, more importantly, what it means for our future. So, what's the absolute biggest threat to humanity today? It's incredibly easy to jump to conclusions, right? You might think of geopolitical conflicts, runaway AI, or even cosmic events. But scientists overwhelmingly warn us that the real answer isn't an asteroid, and it's not a conventional war. No, the single most profound systemic threat we face is the gradual, relentless global warming of Earth itself. To unpack all this, we'll follow a clear path today. We'll start with number 1, the invisible threat, followed by number 2, warming versus climate change. Then number 3, human causes and culprits. Number 4, a world under stress. Number 5, front lines, the Pakistan crisis. And finally, number 6, taking action today. All right, let's dive into section 1, the invisible threat, understanding the real danger. A crucial reality we absolutely have to accept right off the bat is that global warming isn't some distant science fiction scenario that we can just politely push off onto future generations. It's an active, ongoing crisis unfolding right outside our doors. And, the sheer speed of this shift is what's truly alarming. Thanks to a massive global network of ocean buoys, atmospheric sensors, and satellites, scientists are actively measuring rising average temperatures in real time. We aren't just relying on theoretical projections here. We are literally watching centuries-old glaciers retreat before our eyes, and we're recording sea levels steadily inching upward year over year. This acceleration makes it a very tangible, immediate crisis. It's our current reality, and it demands our attention right now. Moving on to section 2, warming versus climate change, defining the terms. To really get a grip on the mechanics here, it's vital to recognize that the greenhouse effect is actually a naturally safe, completely essential process. It's basically our planetary Goldilocks zone. Not too hot, not too cold. Without specific gases in our atmosphere trapping some of the sun's reflected heat, Earth would just be a frozen rock, completely incapable of sustaining life. But the crisis we face today is that human activity has fundamentally altered that atmospheric chemistry, pushing this natural process into totally unprecedented territory. By pumping excessive amounts of carbon dioxide and methane into the air, we're essentially thickening that invisible atmospheric blanket. The heat from the sun comes in, but way less of it is allowed to escape back out into space. That disrupts the delicate thermal balance our ecosystems desperately rely on. Now, this brings us to a crucial distinction that often gets mixed up in public discourse, and that's the difference between global warming and climate change. Think of global warming as the overarching engine. It's the core driver, the literal, long-term thermodynamic increase in Earth's average surface temperature caused by that amplified greenhouse blanket we just talked about. Climate change, on the other hand, is like the chaotic exhaust. It represents the broad, localized symptoms of all that extra heat energy. Because our planet's weather systems are driven by temperature differences, adding massive amounts of heat alters literally everything. So global warming is the accumulation of the heat, while climate change is the resulting atmospheric response. The shifting jet streams, the altered rainfall patterns, and the dramatically increased storm intensity. Let's jump into section 3, human causes and culprits. What is driving the change? So this rapid spike in global temperatures is driven by a deeply interconnected web of human activities. First and foremost, we have the burning of fossil fuels, coal, oil, and natural gas. This essentially takes carbon that was safely locked underground for millions of years and injects it straight into our active atmosphere. But honestly, that's only half the story. At the exact same time we're pumping all this new carbon into the air, mass deforestation strips the Earth of the very forests it relies on to absorb and cool that carbon down. It creates a devastating compounding effect. Add in heavy industrial pollution, the massive methane emissions from livestock agriculture, and keep in mind, methane is a gas that traps heat roughly 80 times more effectively than carbon dioxide in the short term, plus the immense energy demands of rapid urbanization. Put it all together, and these systems form a powerful feedback loop that's basically cranking up the global thermostat. Which brings us to section 4, a world under stress, the global consequences. The consequences of all that trapped heat play out like a massive planetary domino effect. Because the Earth's average temperature is rising, over 90% of that excess heat is actually absorbed by our oceans. These hyperwarmed oceans then act like massive batteries, injecting tremendous amounts of energy into storm systems, which directly translates into stronger, far more destructive hurricanes and cyclones. Simultaneously, warmer air holds a lot more moisture. This means that when it rains, it unleashes historic, intense downpours, but it also rapidly evaporates moisture from the soil, leading to prolonged megadroughts in other areas. This dry, baked landscape creates the absolute perfect tinderbox for explosive, intense wildfire seasons. The warming is fundamentally redrawing the map of where species can actually survive, leading to devastating biodiversity loss, as plants and animals just fail to adapt quickly enough to these radically shifting ecosystems. Let's look at a specific example in Section 5, Frontlines, the Pakistan Crisis, a localized impact study. When we look at global warming, we really have to consider a staggering inequality. The harsh reality of atmospheric physics is that the warming doesn't care where the carbon actually came from. Take Pakistan, for example. Their total historical contribution to global greenhouse gas emissions is less than 1%. It is an incredibly tiny fraction. They are barely contributing to the root cause of the warming planet, yet the data continually shows they rank right among the absolute most vulnerable countries on Earth when it comes to suffering the systemic consequences. Because of global warming, Pakistan is actively navigating a brutal, multi-front environmental crisis. They're facing life-threatening heat waves that literally push the limits of human survivability. But perhaps the most profound systemic shock is occurring in their northern regions. This area is often referred to as the third pole because of its massive glacial ice reserves. Rapid atmospheric warming is melting these glaciers at just an unnatural pace. And this creates a terrifying paradox. In the short term, the accelerated melt triggers horrific, catastrophic flash floods downstream, destroying infrastructure and displacing millions of people. Yet in the long term, depleting those very same ice reserves completely eliminates the crucial, steady water supply they need for drinking and agriculture during the dry seasons. This 1-2 punch of extreme flooding, followed immediately by severe water shortages, decimates agricultural productivity, ultimately placing an entire nation on the brink of severe food insecurity. Now for the most important part, Section 6, taking action today, what we can do. So, combating global warming absolutely requires systemic, macro-level decarbonization. Governments and global industries hold the lion's share of the power to fundamentally rewrite our energy infrastructure. International agreements are the necessary foundation here, right? They coordinate the massive capital required to transition entire national grids away from fossil fuels and toward clean, renewable energy. These high-level treaties also enforce the protection of vital global forests and fund climate resilience projects for developing nations. This top-down approach is essential because, let's face it, we need structural changes to how modern civilization generates power and manufactures goods. But while that foundation is built internationally, the actual execution relies heavily on local implementation and our collective demand. The power to shift the narrative definitely doesn't belong solely to governments. The power of aggregate demand is immense. When millions of individuals adopt structured habits, markets and supply chains are literally forced to respond. The first step involves targeting your own daily energy footprint. Simple choices, like optimizing your home electricity usage, opting for renewable energy providers if you can, or utilizing public and efficient transport, directly reduce your daily carbon output. The second step tackles our resource consumption. Consciously reducing single-use plastics, recycling properly, and conserving water lessens the industrial energy required for manufacturing and processing. Finally, step 3 is proactive advocacy. Whether it's planting trees to naturally restore local carbon sinks, or just voting with your wallet to support sustainable green initiatives in your community, these actions really compound. Millions of localized decisions merge together to create massive, systemic, global relief. I'm going to leave you with this very clear reality. The future of Earth truly depends on the decisions we make today. Global warming is without a doubt the defining systemic challenge of our century. The physics are completely clear, and the localized impacts are already disrupting millions of lives around the globe. But our trajectory isn't locked in just yet. Every single megawatt of clean energy deployed, every ecosystem protected, and every sustainable choice reshapes tomorrow. The tools and technologies for a cooler, more stable planet are already right here in our hands. So the only real question left is, will we deploy them fast enough?